The Pythagorean theorem can be applied to three-dimensional figures. In this figure here, we have a pyramid. A is going to be considered the slant height. This is the height of the triangular face of the pyramid. B is going to be considered to be 1/2 of the base length of the pyramid. It goes from the midpoint of the side of the base to the center of the base of the pyramid. And then H is going to be considered the height of the pyramid. It goes from the base of the pyramid to the top of the pyramid. Now, as you can see, a right triangle is formed between the three lengths of A, B, and H. B and H are considered the legs, and A is considered the hypotenuse. So if you know two of the measurements, you can calculate the third using the Pythagorean theorem. So here's an example. We have find the slant height of a pyramid whose base has a length of 8 centimeters and has a height of 5 centimeters. So we know that if the base has a length of 8 centimeters, that's the entire base, so B is going to be half of that amount, and B will equal 4. We're told the height is 5 centimeters, so H equals 5. And if we want to find the slant height, that's the missing height, so that's the value of A. So we can use the Pythagorean theorem, thinking that our legs are B and H, and C, our hypotenuse, is actually equal to A, the slant height. So if A squared plus B squared equals C squared, we can substitute in our values for 4 squared plus 5 squared now equals A squared. Simplifying and taking the squares, we have 4 squared is 16, 5 squared is 25, 16 plus 25 equals 41, and taking the square root of both sides gives us that A is approximately 6.4. So that means our slant height is approximately 6.4 centimeters. We were able to find it using the Pythagorean theorem. Another example here, we have find the slant height of a pyramid whose base length is 10 centimeters and whose height is 12 centimeters. And it wants us to label the diagram with the measurements. So we don't know the slant height, that's the value of A, so that's what we'll label our slant height in our pyramid with. That's our unknown we're trying to solve for. The entire base length is 10 centimeters, so B is going to equal 5. It's going to equal half of that amount. And the height is 12 centimeters, so H equals 12. We can now use these values of B and H to solve for that missing hypotenuse to give us the slant height. So B equals 5, H equals 12, and A we don't know. So we'll use A squared plus B squared equals C squared to solve for that value of A. We'll substitute in A and B with the values of B and H, so that will give us 5 squared plus 12 squared equals A squared. 5 squared simplifies to 25, 12 squared simplifies to 144, and 25 plus 144 equals 169. And taking the square root of both sides gives us the value of A equal to 13. So if A equals 13, we now know the slant height is 13 centimeters. Again, we were able to answer that question using the Pythagorean theorem. Let's do one more example where we're not finding the slant height, but now we want to find the base length of the pyramid whose height is 21 meters, and there's a slant height of 29 meters. So we'll label the diagram now with these measurements. Now we know the value of A. The slant height we're told is 29 meters. And we know the height is 21 meters, so H will equal 21. So we're looking for the value of B because then we can multiply it by 2 to find that base length of the pyramid. So here we have A equals 29, H equals 21. Again, we're trying to solve for B. So we'll use the Pythagorean theorem, A squared plus B squared equals C squared. Now, our hypotenuse this time is the value of A, which is 29. And then we have one of the legs is H, so that's 21. So we don't know that one leg of B, so we'll use that as the first leg of A. So it's a little confusing with the different variables, but just keep yourself organized that B and H are the legs. So those are A and B in the Pythagorean theorem. And A, the slant height, is always the hypotenuse, so that's your value of C. So when we make our substitution, we end up with the equation b squared plus 21 squared equals 29 squared, and we want to solve this for B. So 21 squared is 441, 29 squared is 841, so we'll subtract 441 on both sides, giving us that b squared equals 400, and taking the square root of both sides gives us that b equals 20. So again, if b equals 20, that's half of the base length, so multiplying 20 times 2 will give us that the entire base length is going to be 40. So it's 40 meters for that base length, again, using the Pythagorean theorem to help us find that answer. You can use the Pythagorean theorem for any application problem as long as you can find that right triangle. And then you can find out whether you're solving for a leg or a hypotenuse.